Good day, everybody. How are you doing? Today we are going to talk about formula for confidence interval for population proportion P. P is the population proportion of success. P hat is the sample proportion of success given by x over n, where x is number of successes in the sample and n is the sample size. Okay, so P is the population proportion of success. Okay, now P hat is x over n. Instead of reaching the entire population, I will select a simple random sample of 100. An example is, suppose I want to find the population proportion of students who have laptop computers. So I'll select a simple random sample of size 100 and find out that out of them 60 have laptop computers. So my sample proportion of success is P hat, which is 60 over 100 or zero point 0.6 sample proportion of students with laptops. Now P hat is the single point estimate for population proportion P. Let's see my confidence level. 1 is equal to 1 minus alpha, or alpha equal to 1 minus C. What is alpha? Alpha is the significance level, is the maximum probability of making an error. If my C is 0.95, that means I will have 95% confidence in the interval that I will determine to find the population proportion. Okay, if C is equal to 0.95, then alpha is equal to 1 minus 0.95 or 0.05, or alpha by 2 is 0.05 by 2, 0.025. C of 0.95 means the central area is 0.95. We will be confident, 95% confident, that the interval which we will construct for the population proportion will contain the actual proportion, population proportion. So if the central area is 0.95, then area of these two tails is 1 minus 0.95, because the total area under the curve is 1. 1 minus 0.95 is 0.05. So these are area of the two tails. So area of each tail, because this standard normal curve is symmetric, area of each tail is alpha divided by 2, or 0.05 divided by 2, called 0.025. Now we can use TI-84 to find this value of minus Z alpha by 2. So we will press second key, then verse key, then we'll scroll down to INNORM, which is number 3. It's asking for an area, which is the area in the left tail. It's 0.025, and mu is 0 because this is the standard normal curve. Sigma is 1, and we scroll down to paste and then hit enter and enter, and we will get minus Z alpha by 2 is minus 1.96 by symmetry, because remember this standard normal curve is symmetric, so Z alpha by 2 is 1.96. Minus Z alpha by 2 and Z alpha by 2 are called the critical values of Z, because they separate the most probable region, the central area, which is sea level 1 minus alpha, from the two tail areas. So most probable region where the population proportion will fall, and the least probable region is in the two tails, where the population proportion will most likely not fall, or most likely not lie. So this is called a critical value, because it separates the least probable region from the most probable region. Okay, now I'm drawing, or I have drawn, the sampling distribution of P hat. That is, P hat is on the horizontal axis and you have relative frequency on the vertical axis. Again, the central area is where the population proportion will fall, and that is equal to 1 minus alpha, where alpha is level of significance. Area of each tail is alpha by 2. Now, from the definition of the standard normal variable, it is given by how far the P hat is located away. P hat, remember, is the sample proportion, located away from the population proportion divided by the standard error. Standard error is the standard deviation of the sampling distribution of P hat, and it is equal to square root of P, population proportion, times 1 minus P divided by N. Similarly, minus z alpha by 2 is also sigma p hat minus p divided by sigma p hat. Now from the first equation, we can solve for p hat. P hat is equal to p plus z alpha by 2 times sigma p hat. And from the second equation, we get p hat is equal to p minus z alpha by 2 multiplied by sigma p hat. This is the lower boundary and this is the upper boundary of the interval within which most probably p hat will fall. So p hat, this is the lower boundary, p minus sigma minus z alpha by 2 times sigma p hat less than p hat less than p plus z alpha by 2 times sigma p hat. So these are the two boundaries within which p hat will fall. Now we will subtract p from all of them. So we get p is removed minus z alpha by 2 times sigma p hat less than p hat minus p is removed, z alpha by 2 times sigma p hat. Okay. Now we will subtract p hat from all of them. So we get minus p hat minus z alpha by 2 times sigma p hat less than minus p less than minus p hat plus z alpha by 2 times sigma p hat. Now we will divide all of them by minus 1. But when we divide by a negative number, the direction of inequalities will change. So the left boundary minus p hat divided by minus 1 is p hat minus z alpha by 2 times sigma p hat divided by minus 1 is plus 1 times plus 1 z alpha by 2 sigma p hat. This less than flips over, changes direction, greater than minus p divided by minus 1 is p, and then less than becomes greater than p hat, and minus p hat divided by minus 1 is p hat plus z alpha by 2 sigma p hat divided by minus 1 is minus z alpha by 2 times sigma p hat. So this stuff is the greatest and this type is the least. P hat plus z alpha by 2 times sigma p hat is the greatest value or the highest point of the boundary or the upper boundary, and p hat minus z alpha by 2 sigma p hat is the lower boundary of this interval for p. So if we write it in a different way, put the lower boundary first, p hat minus z alpha by 2 times sigma p hat less than p less than p hat plus z alpha by 2 sigma p hat. So this is the lower boundary, p hat minus z alpha by 2 times sigma p hat, and the upper boundary is p hat plus z alpha by 2 times sigma p hat. Now the term z alpha by 2 times sigma p hat, which is the critical value of z multiplied by the standard error. This is called margin of error. So basically p is given by the lower boundary, the confidence interval for p. The lower boundary is p hat minus margin of error. The upper boundary is p hat plus margin of error. Of course, the margin of error will depend on how much confidence level we want to have, and also will depend on the standard error or sigma p hat. So I'll stop here today. If you have any question, you can always write me a comment and I'll get back to you as soon as possible. And please subscribe to my channel by hitting the red subscribe button, because I have solved all kinds of stat problems for you. So by subscribing to my channel, by hitting the red subscribe button on the bottom right corner, you'll get free access to all kinds of stat problems solved just for you. Take care, have a nice day, and I'll come back next time where I will explain the formula for confidence interval for the population mean mu. Thanks. See you tomorrow. Take care. Bye.